Welcome back to AI Podcasts. I'm Daniel Park, and today we're unpacking a new ICLR 2025 poster called MTU-Bench, short for Multi-granularity Tool Use Benchmark for Large Language Models.
Hey Daniel, I'm Maya. Give me the quick takeaway first. What's the headline?
TLDR, the authors built a benchmark and a companion training set that let you test how well language models use tools across 5 realistic situations, from single-turn to multi-turn, and from one tool to many, plus an out-of-distribution split. The evaluation is automatic, so you don't need GPT or human graders to score results. In broad strokes, top proprietary models still lead, but fine-tuning open-source models on this data narrows the gap. Multi-turn, multi-tool tasks remain the hardest.
Got it. Who's behind this work?
It's led by Wang, Yanan Zekun, also known as Noah Wang, and the corresponding author Jiaheng Liu, with collaborators from Alibaba Group, the University of Chinese Academy of Sciences, and the University of Waterloo.
Thanks. So what problem are they trying to solve here?
Tool use is when a model calls external functions. Think calendars, search, booking APIs, or calculators to complete real tasks. Benchmarks exist, but many either cover narrow situations, like one turn with one tool, or they rely on GPT as a judge to grade open answers. That can be expensive, hard to reproduce, and sometimes subjective. The gap is a benchmark that matches real assistant behavior across different scenes while scoring in a precise, automatic way.
Right, because a helpful assistant might search, plan, then book, and confirm, not just call one tool once.
Exactly, and there are different ways to fail: choosing the wrong tool, passing the wrong parameters, or calling tools in the wrong order. MTU-Bench tries to measure those specifics rather than just pass or fail at the end.
How does this compare with earlier benchmarks?
Earlier efforts like API Bank and API Bench moved the field forward, but they often lacked full coverage of multi-turn or multi-tool planning, leaned on GPT graders, or used coarse metrics. MTU-Bench addresses those pain points by spanning single and multi-turn, single and multi-tool, including an out-of-distribution split, and by offering fine-grained automatic metrics.
Okay, so what's their big idea?
2 parts. First, they build data from task-oriented dialogue corpora by mapping intents to tools and slots to parameters, then synthesizing tool calls and observations. That yields MTU Instruct for training and MTU Eval for testing. Second, they define automatic fine-grained metrics so you can score predictions directly from model outputs without a judge in the loop.
When you say synthesize, do they use live APIs?
No, they simulate the tool responses. The pipeline uses GPT-4 and rules to generate tool calls, parameters, and observations, followed by quality checks, including manual review. It's designed for scale and reproducibility, though it doesn't capture real API quirks like latency or authentication issues.
That sounds practical for benchmarking. What does the dataset look like?
It's large and diverse, roughly 55,000 dialogues and a catalog of 136 tools. The evaluation covers 5 scenes: single-turn single tool, single-turn multi-tool, multi-turn single tool, multi-turn multi-tool, and an out-of-distribution split where topics differ from training.
And the metrics? Walk me through them without getting too mathy.
For single-tool cases, they check whether the model picked the right tool and whether it filled parameters correctly. For multi-turn, they track turn-by-turn success and a softer version that discounts turns right after an error, plus overall dialogue success. For multi-tool, they look at whether the model used the right set of tools and whether it called them in a sensible order. There's also a task progress measure: how far the model gets before its first mistake.
I like that last one. Real users appreciate getting most of the way there, even if something minor goes wrong.
Exactly. It's a more informative signal than all-or-nothing success.
How did they test models, and against what?
They evaluated a mix of closed-source and open-source models, then fine-tuned some open models on MTU Instruct to create variants like MTU Llama. Results are reported on a normal test set, a curated hard set with trickier cases, and the out-of-distribution split.
And what stood out in the results?
Patterns you'd expect showed up. On the normal set, top proprietary models generally lead, especially in multi-tool settings. Fine-tuned open-source models improve noticeably and narrow the gap. On the hard set, rankings shuffle. A model that looks strong with one tool isn't always robust when several tools and longer plans are involved. The common thread is that multi-turn, multi-tool remains challenging. The authors also show cases where Quen models and their fine-tuned MTU llama variants hold up well in multi-tool or out-of-distribution tests, including competitive results on API Bank.
Where do models go wrong most often?
Action errors dominate, choosing the wrong tool for a step. Parameter mistakes come next. Format issues like malformed calls show up more in smaller or weaker models and drop with targeted fine-tuning. There's also a clear scaling effect. Larger or better-tuned models generally handle structure and sequencing better.
Do their automatic metrics line up with what humans would say?
The scoring itself is fully automatic and doesn't rely on GPT or human graders. That said, the team performed manual quality checks on the test set during construction, which helps trust the evaluation data even though the final scoring is automated.
Any concerns or caveats we should keep in mind?
A few. First, the tools are simulated, which is great for control and cost but doesn't capture real-world API friction, like latency, partial failures, or changing data. Second, GPT-4 is used in the data generation and filtering pipeline, so the data set may carry some bias from that model even if GPT isn't used during scoring. Third, planning often has multiple valid paths. Even with tolerant metrics, a single reference plan can undercredit creative but correct strategies. And finally, while the data set includes explicit reasoning fields that help supervision, there's always a risk of overfitting to a particular thinking aloud style rather than building genuinely robust tool use.
Before we wrap, give me a quick mental picture of why multi-tool planning is hard.
Think of a travel task. A model might need to search flights, check a calendar, book a ticket, and then send a confirmation. If it jumps to booking before checking constraints, it may pick the wrong flight. If it forgets a parameter from an earlier turn, the call fails. And if the ordering is off, say, it tries to confirm before it books, the whole plan unravels. MTU-Bench explicitly scores those aspects so you can see where a model stumbles.
That example lands. So what should researchers and builders do with this benchmark?
Use it to stress test assistant behavior beyond happy path demos. If your model looks great on single-tool tasks, see how it handles multi-turn, multi-tool cases, and the out-of-distribution split. If you're training, try fine-tuning with MTU instruct-style data and watch which error types drop. And for product teams, choose the metrics that match your workflow risk, tool order if sequencing is critical, or task progress if partial progress still helps users.
And future directions?
3 practical ones. Bring a slice of live tools into the loop to test recovery from real failures and latency. Broaden the reference plan so alternative correct strategies get proper credit or use equivalence checks where you can. And extend to longer horizons, more languages, and mixed modalities with safety tests for prompt injection resilience and cost-aware planning.
Summing up, MTU-Bench gives the community a more complete, reproducible way to measure tool use, with training data that helps open-source models become more capable.
Well put. It's not the final word, but it's a solid step toward evaluating assistants the way we actually use them. Thanks for listening. This has been AI Podcast.